Hey guys, today I will be teaching about combination circuits, which are a combination of series and parallel circuits. As you can see, points A and B are in a parallel circuit, while C and D look like a series circuit. What we want to do is turn any parallel portions into an equivalent series connection so that the whole circuit will become a series circuit. So in this picture, diagram A is a combination circuit in which R2 and R3 are a parallel branch with equal resistance. In the case of equal resistance, you can take the resistance of one branch and divide it by the number of branches. In this case, the resistance of one branch is 4 ohms and there are 2 branches. 4 divided by 2 gives you a resistance of 2 ohms, as depicted in diagram B. This next problem is similar to the previous one, but the resistance is not equal at the parallel connection. So we have to use this first equation in red to figure out the resistance. 1 divided by the overall resistance is equivalent to the sum of the reciprocal of the resistance at each branch. That might have been a little wordy, but the equation is pretty straightforward. In this problem, we plug in 4 and 12 and solve to get 0.33 ohms to the negative first. This is equivalent to 3 ohms, which is our final answer. This final answer can be substituted in so that this combination circuit becomes a series circuit. We can then solve for the total resistance in the circuit by using the second equation in red, giving us an answer of 16 ohms. Now we can solve for the current and voltage at each point. We already solved for the total resistance, which is 16 ohms, and we can apply Ohm's law, voltage equals current times resistance, to find the remaining values. Given a total voltage of 24V from the battery and a total resistance of 16 ohms, we can solve for I and find that the total current is 1.5 amps. The current between series connections stays the same, so the first and fourth points have a current of 1.5. In order to find the current for the points that were in the parallel connection, we need to first solve for the voltage drop. This can be solved by finding the voltage drop of the first and last resistors and subtracting that from the total voltage. Using Ohm's law to find the voltage of the first and last resistor, we can then subtract the sum of these voltages, which is 19.5, from the overall voltage of 24 to find the voltage of the parallel branch, which is 4.5. And so we found all the voltages. Our last step is to find the currents of the parallel connected resistors using the voltage drop. Once again applying Ohm's law, we can easily solve for each value. And this completes our problem on combination circuits.